Magandang araw mga batang mandunong. Tayo nang mag-aral para sa week 7 sa first quarter. Ako pala si Mr. Jomy de los Santos Yucampo, a grade 7 mathematics teacher of Ilaya Barangka Integrated School. Mga batang mandunong, tayo nang mag-aral ng quarter 1 week 7, module 7, estimating square roots. Here is the objective of the lesson. The learner approximates the value of the square root of a whole number to the nearest hundreds and plot it to the number line. Square roots. If a is greater than 0 and a multiplied by a is equals to a squared, then the square root of a is equals to a. The square root of a given number is a number whose square is the given number. The symbol, the square root, is used to denote the square root and known as the radical sign. The number under the radical sign is called the radicand. The positive square root of a positive real number is called principal root. If the square root of a is an integer, then the number a is called a perfect square. Here are some examples of a perfect square. The square root of 1 is equal to 1. The square root of 4 is equal to 2. The square root of 9 is equal to 3. The square root of 25 equal to 5. The square root of 36 equal to 6. The square root of 14 is equal to 7. The square root of 64 is equal to 8. The square root of 81 is equal to 9. The square root of 100 is equal to 10. The square root of 121 is 11. The square root of 144 is 12. The square root of 169 is 13. The square root of 196 is equal to 14. And the square root of 220 equals to 15. And we have higher number or higher perfect square than 225. It means, class, if we double 1 times 1, that is our radicand 1. If we double 2 times 2, that is the radicand 4. If we double 3 times 3, that is the radicand 9. If we double 5, that is 25, the radicand 25, and so on. Let's have an example number 1. What is the principal root of the following? The square root of 9. So, 3 squared is equals to 3 times 3, which is equal to 9. So, therefore, the square root of 9 is 3. And that is the principal root of the square root of 9. Another one, letter B. The square root of 64, that is 8 squared, which is equals to 8 times 8 is equals to 64. Thus, the number 8 is the principal root. Let's take letter C. The square root of 169, which is equal to 13 squared. 13 squared means 13 times 13, which is equals to 169. So therefore, the principal root of the square root of 169 is 13. Example number 2. Between which two consecutive integers does its number lie? We have here the square root of 40. We know that 40 is not a perfect square. So the solution is 6 and 7. We know that 40 lies between the two perfect square, 36 and 49. Hence, the 36 is less than 40 and 40 is less than 49. So therefore, the square root of 36 is less than the square root of 40, and the square root of 40 is less than the square root of 49. Thus, 6 is less than square root of 40, and the square root of 40 is less than 7. Next, we have the square root of 125. To get 11 and 12, we know that 125 lies between the two perfect squares, which is the square root of 121 and the square root of 144. Because the square root of 121 is 11 and the square root of 144 is 12. Hence, 121 is less than 125 and 125 is less than 144. So therefore, the square root of 121, which is 11, is less than the square root of 125, and the square root of 125 is less than the square root of 144. Thus, 11 is less than the square root of 125, and the square root of 125 is less than 12. Let's have another example, letter C. We have here the square root of 199. We know that the square root of 199 is not a perfect square. To get the solution of 14 and 15, we know that 199 lies between the two perfect squares, 196 and 225. Because the square root of 196 is 14 and the square root of 225 is 15. Hence, 196 is less than 199 and 199 is less than 225. So therefore, the square root of 196, which is 14, is less than the square root of 199, and the square root of 199 is less than the square root of 225, which is 15. Thus, 14 is less than the square root of 199 and is less than 15. To determine the approximate value of the square root of a not perfect square number, a series of estimation is needed. Here are the symbols used for approximation. Let's take the first example of approximation. Let's approximate the following to the nearest hundreds. Let's have the square root of 2. We know very well that square root of 2 is not a perfect square. So here is the solution. If we're going to key in our calculator the square root of 2, that will give 1.41. So the approximate value of the square root of 2 is 1.41. Here is the first step. Determine between which two consecutive integers does the square root of 2 lie. We know that 2 lies between two perfect squares, which is the square root of 1 and the square root of 4. Hence, 1 is less than 2 and 2 is less than 4. Or the square root of 1 is less than the square root of 2 and the square root of 2 is less than the square root of 4. Thus, 1 is less than the square root of 2 and the square root of 2 is less than 2. Step number 2. Start estimating by getting the squares of the following. Let's approximate 1.1, 1.2, 1.3, and to 1.9. Our problem is the square root of 2. So, if we're going to square 1.2, that is equal to 1.2 times 1.2, that is equal to 1.44. 1.3 squared, that is equal to 1.3 times 1.3, that is equal to 1.69. 1.4 times 1.4 or 1.4 squared, that is equal to 1.4 times 1.4, which is equal to 1.96. And then 1.5 squared, that is equal to 1.5 times 1.5, which is equals to 2.25. Since our problem is the square root of 2, so that is in between 1.96 and 2.25. So, the square root of 2 must lie between 1.4 and 1.5. Step number 3. Repeat estimating by squaring the following. Let's approximate 1.41, 1.42, 1.43 up to 1.49. So, 1.41 squared, that is equal to 1.41 times 1.41, and that is equal to 1.9881. If we're going to square 1.42 square, that is equal to 1.42 times 1.42, that's equal to 2.0164. Therefore, the square root of 2 lies between 1.41 and 1.42. Now, let's have example number 2, the square root of 7. If we're going to approximate the square root of 7, that will give us 2.64. And if we're going to key in the square root of 7 in a calculator, that will give us 2.64. So the approximate value of the square root of 7 is 2.64. Let's have step number 1. Determine between which two consecutive integers does the square root of 7 lie. We know that 7 lies between two perfect squares, 2 and 3. Hence, 4 is less than 7 and 7 is less than 9. Or the square root of 4 is less than the square root of 7 and the square root of 7 is less than the square root of 9. Thus, 2 is less than the square root of 7 and the square root of 7 is less than 3. Step number 2. Start estimating by getting the squares of the following. Let's estimate 2.1, 2.2, 2.3, up to 2.9. If we're going to square 2.4 squared, that is equal to 2.4 times 2.4, and that is equal to 5.76. If we're going to square 2.5, that becomes 2.5 times 2.5 and will give us 6.25. If we're going to square 2.6 squared, that becomes 2.6 times 2.6 and that is equal to 6.76. If we're going to square 2.7 or equal to 2.7 times 2.7, that will give us 7.79. Hence, the square root of 7 must lie between 2.6 and 2.7. Step number 3. Repeat estimating by squaring the following: 2.61, 2.62, 2.63, up to 2.69. So if we're going to square 2.61, that is equal to 2.61 times 2.61, that is equal to 6.8121. If we're going to square 2.62, that is equal to 2.62 times 2.62, that is equal to 6.8644. If we're going to square 2.63 squared, that is equal to 2.63 times 2.63, which is equal to 6.9169. If we're going to square 2.64 squared, that is equal to 2.64 times 2.64, that is equal to 6.9696. And if we're going to square 2.65, that is equal to 2.65 times 2.65, which is equal to 7.0225. Therefore, the square root of 7 lies between 2.64 and 2.65. This time, let's plot the following on the number line. We're going to plot the square root of 3, the square root of 10, the square root of 27, and the square root of negative 8. Solution. To plot the numbers on the number line, get the approximate value of each by series of estimation that we do on example. Letter A, the approximate value of the square root of 3 is 1.73. The approximate value of the square root of 10 is 3.16. The approximate value of the square root of 27 is 5.19. And letter D, the approximate value of negative the square root of 8 is negative 2.82. And then we're going to plot this one in the number line. To plot our answers in the number line, we have the value or the approximate value of negative the square root of 8 is negative 2.82, and the approximate value of the square root of 3 is 1.73, and the approximate value of the square root of 10 is 3.16, and the approximate value of the square root of 27 is 5.10. That's how we plot our square roots in the number line. Once again, this is Sir Jomy de Los Santos Ocampo of Ilaya Barangka Integrated School. Thank you everyone for watching.